Okay, good morning. This morning we're going to start on the middle of section 2, which kind of introduces us to the big idea about logarithms. I added in this last section, so if you guys pre-printed the slides out, can you guys also add into that first slide that we are going to do a little intro to 2.09? So we are going to do a quick introduction to solving equations, which is 2.09. And that will bring us through Thursday of this week. Because logarithms is a really huge idea, and it's really important to make sure that you guys know the basics before we kind of trudge a little bit deeper next week. The only part that is not included in your pre-printed notes is your Week 7 essential question. So please take a quick moment and copy it down. So even though the people who are in person get full credit for attending, I'd still like them also to write the essential question down because it's important to me that you guys know how to answer this question by the end of the day. It's sort of our big idea, where we're headed, what we want to accomplish. So for this week, your question is, why do we use logs? And please describe the steps to solve this problem and give me the final answer. Because that's really going to show me whether or not you understand when to use a log and how you use it and what you get for your final answer. So kind of jumping into what a logarithm is, it's how do you solve a question like this? Now, before we actually solve that problem, I want us to think back quite a few units, quite a few years to Algebra 1. If I said 2x equals 10, how do you guys get the x by itself? What do you have to do? Divide by 2. So you're actually doing the opposite operation of what you see. Am I right in saying that? Are we okay with that vocabulary? So in order to get x by itself, I have to do the opposite operation of what I'm seeing there. So if I had an add, we know the opposite would be subtract. Here I have a 2 raised to the x. That's weird. I have never before had a variable as an exponent. So I need to be thinking to myself, what is the opposite of having a variable in my exponent? And before now, we've never had an answer to that question, ever. Because let's think about this for a minute. If I put 2 and I thought that x was 2, what's 2 squared? 4. What if I thought that x is 3? What's 2 to the third? 8. What's 2 to the fourth? So 2 times 2 times 2 times 2. 16. So wait a minute. I wanted what value of x is going to give me a 10. That means my answer is somewhere in between here. Did you guys see what I did? That means my answer is somewhere between a 3 and a 4. My x is going to be a decimal. That's weird. We've never had decimals as an exponent before. So how am I going to be able to solve for that exact value? I'm going to use logarithms. Kind of cool. So when do we use logarithms? Whenever you have an exponent that is a variable. So I'll say that again. When do we use logarithms? Whenever we have exponents that are variables. Because never before have we ever tried to solve for a variable as an exponent. This is new for us. So when do we use logs? When we have a variable that's an exponent. Just like when do I use division? When it's multiplied. When do I use subtraction? When it's added. When am I going to use a logarithm? When you have a variable that's an exponent. Okay, so with that in mind, I'm going to teach you a couple logarithm rules and then we're going to try a few of them. So here's your definition of a logarithm. And I realize that whenever the book shows you a definition, they only use letters, and it's really confusing because there's lots of letters going on here. So we're going to put numbers to it and see if we can make sense of this thing. So here we go. Instead of B, I'm going to put a 2. So right underneath this slide, can you guys write in this example? Instead of X, I'm going to put a 3. And instead of A, that would be an 8. So before I go any further, is that a true statement? Is 2 to the third power 8? Yes. We're going to learn how to write it in logarithmic form. So take a peek over here how it's going to change. So see if you can replace the numbers that we just did into my logarithm format. See if you can replace your x your B, and your A. I'll give you just a second to see if you can rewrite it. It's weird, I know. It'll take some getting used to. So where the X is, you're going to put the 3. Where the little b is, we're going to put the 2. And where the a is, we put the 8. So all I did was I was taking the numbers that I'm replacing these with, and I'm putting them in this new format over here. So the little x was a 3, so that means this x is a 3. My b was a 2, so that means this little b is a 2. Here's how I like to think of it. I actually write my logs backwards, which most books are going to do for you as well. And when I say backwards, here's what I mean. I'm going to put the log 2 and the 8 with the 3 on the other side. So can you guys also write it like that? I'm going to show you why I do it this way in just a minute. So all I did was move the equals 3 to the other side. Everybody agree with that? That's all I did? Move the equals 3 to the other side. Watch how you take a logarithm and put it in exponential form. You do the little base, raise to the other side, so 2 to the third equals 8. See how that's what we got over here? So little base, raise to the other side, equals 8. That's how you put it back in this format, back in exponential format. So I'm going to write you a new log, and I'd like you to write it in exponential terms. So here, log 2, 16 equals 4. Can you guys take that logarithm and rewrite it as an exponential, please? So you guys have some lines next to these slides on your note sheet, so go ahead and just write it right in there. Okay, who's brave? Who'd like to try? Jordan, you want to try?
Sure.
Okay, what did you get?
2 to the 4th power equals 16.
Great job. Okay, so the reason, one more time, I like my log to be on the left, my answer to be on the right, is because then for me, it's more easier for me to see it changing from this format to this format. It's always the little base raised to the other side equals your big number. 2 to the 4th equals 16. How did we do on that one? Okay? I know it's new, it's weird, it's new, we're just practicing. I'm going to give you the exponential, and I want you to write the logarithm. Okay, so we're going to go back the other direction. I'm going to hide this. I'm going to make some space for myself. So you guys can use more of your line space. Okay, I want you to show me, let's say, 3 squared equals 9. Can you please write that in log format for me? Okay, so let's check our work. So it'd be log base. What's the little b going to be? 3. Oh, is it 2 or is it 3? Log base 3, 9 equals 2. Check yourself going backwards. I always think it's easier to go from the log back to the exponent. Check yourself. The little base raised to the other side equals this number? Yes. 3 raised to the 2 equals 9.
Wait, that's 3 raised to 2 equals 8?
No, what's 3 squared?
Oh, I'm sorry.
No, you're good.
Oh, okay, sorry.
Does that make sense?
2 to the 3rd.
Yeah, it's not 2 to the 3rd, so it's 3 to the 2nd power. So 3 times 3 is 9. Any questions about going back and forth? I'm going to have you try again. We're just practicing right now. You might be thinking, there's no variable in there. There's nothing to solve for. I know. Right now I'm not giving you a variable yet. We're just practicing writing in both formats because we have to be comfortable before we can try solving these things. Let's try another one. Let's do one that we know to be true. Let's say 5 to the 3rd equals 125. Please write that in log format. Okay, Alex, what did you try? Log base 5.
125 equals 3.
Good job. So let's double check ourselves. Is 5 to the third 125? Yes. So I know I set that up correctly. So you might be thinking, well, how is this useful? Because there's no variable. Well, watch if I change this on you. If I said 5 to the x equals 25, I have a variable. Can you guys write that one in log form? We're going to do one more log form and then we'll move forward. Okay, it should look like this. Log base 5, 25 equals x. How'd we do? Hopefully not too bad. So the idea is that you are able to go back and forth, back and forth, back and forth, back and forth, because sometimes if I give it to you in log form and you can put it in exponential form, you can actually tell me what x is right now. 5 to the what power is 25?
2.
5 squared, right? So in this case, x would be a 2. Do I know that x is a 2 in log form? No. So which form is much easier for us to understand? Exponential form. But we have to be able to go back and forth. So if I give you this one on the right, you can write it as the one on the left, and now you can tell me your x is 2. So when they're whole numbers, they're easy. We've been doing exponents for a while now. Whole numbers are okay. Now let's get into when it's not a whole number. So this is what we were just practicing. It's on your slide already. So this one on the left is called exponential form. And think about why it's named that, because it still has an exponent. The one on the right is called log form. Why is it called that? Because it has a log in it. A couple key things to keep in mind as we work through this unit. Excuse me. Anytime you see log 10, that's automatically going to equal a 1. And anytime we see an ln e, that means natural log, that's also going to equal a 1. These are going to come in handy for us as we're solving some problems later today. So can you circle these two for me, please? I do want to add one more thing onto this slide. And do you guys notice how with the logs, there's always a little base, right? This log doesn't have a little base. It's kind of like when we were talking square roots last chapter. Square roots. If I don't give you a little number in the root, what kind of root was it? Do you guys remember? When there's no number there, what is it automatically?
Square.
A 2. Yep, it's a square root. So on a log problem, I'm right here right now, if I don't tell you what little base it is, it's automatically a 10. So go ahead and write that in real fast. So on any log problem, if they do not show you the little number down there, it's automatically a 10. So we're going to try some, but first I have to teach you your log rules. So that was just one of the log rules. That was called definition of log rules. Here's a couple more rules. Now don't freak out on me. There's a lot going on this page. We're going to highlight 3 things only. We're going to talk about the first property, second property, and only the top one of the third property. Can you guys please put stars by those on your notes? The product property, quotient property, and then the top power property. But these are not as scary as they first appear because they have the same rules as exponents. Let me show you what I mean by that. On this product property problem, we have 2 things being multiplied together. Let's think about exponents for a minute. If I had x3 times x2, they're multiplied together, what did I do to their exponent? I added them. Hey, wait a minute. When I have logs and they're multiplied together, what am I going to do to the logs? I'm adding them. It's the same rules as your exponent rules. So just like when I saw multiply with exponents, what did I really do? Added them. What about if I have a division problem? Let's think about that. So if I had x5 divided by x2, what would I get? x3. So what's my division rule? Subtraction. Can you guys highlight all that on your notes just like I did, please? So point out that when it's a multiply, it's really turning into an addition problem. And when it's divide, it's turning into a subtraction problem. It is our same rules as our exponents were. Okay, and then the third one, this power property we're going to use a lot. I'm actually going to put 3 stars by it. You're going to use this one a ton. And basically what it's saying we can do is that when I have an exponent, what I'm allowed to do when there's a log on both sides is I can take that exponent and put it out in front. See how over here on the right, they just took the exponent of p and they stuck it out in front. That's how we're going to get rid of our exponents that are variables. We're going to have logs on both sides and we get to stick it out in front. You're going to see in a couple examples in just a moment. So this is brand new. This is really heavy duty mid-unit stuff right now. So I'm really grateful you're here with me today. So we're going to try a few. They look scary, look kind of crazy. So first I'm going to cover up the top 2. We're going to try the bottom one first. So it says convert the expression to exponential form. This is your basic log definition that we practiced about 5 times on the first slide. I'm just having some recall moments here. See if you can rewrite this in exponential form. What to the what power equals what? Do you remember the pattern? Nikki, you want to try it? What'd you put?
I put 3 to 3rd.
Okay, so I'm glad she said that. Check your work. Is that a true statement? No, so we messed up one spot. Can somebody help her fix it? Math's all about mistakes, right? Trying fixing things, Alex? There you go. 2 to the 3rd equals 8. It's always the little number raised to the other side equals your big number. So again, it just takes practice, to be honest. Like the more you guys practice and do your homework, the better you're going to become at these logs. So now we're going to try the top 2, which are a little trickier. So this time it's saying, take this big long logarithm, and it wants me to write it as a single logarithm. So I want you guys to highlight all of the signs that they're showing you in there. They're showing you a couple different math operations going on. And I know if you don't bring a highlighter, maybe bring a highlighter next time. I love to mark up my notes. I see a subtraction sign. What other sign do you guys see? An addition sign. So a couple slides ago, I showed you those rules and how they're the same rules as exponents, right? So when we see a subtraction sign, I want you to draw an arrow. What does subtraction mean I'm going to do? I'm going to write it as a division problem. And when you see the add, what does the add mean we're going to change it to? A multiplication problem. So see how before I even start my problem, I'm highlighting the key aspects of my problem, which is going to help me solve. So when I write it as a single logarithm, here's the best part. You get to take all of these log base 3's, and we only have to write them one time. So everybody go ahead with me. Let's write our log base 3 out on the left-hand side. And then what am I really dividing and what am I really multiplying? I'm going to highlight those back on my original problem. So we're talking about the 15, the 3, and the 4. So let's recap what we did. We took the log base 3 and we're putting it way out in front. Then we're recognizing that the subtraction means division and the addition means multiplication. So what exactly am I dividing? Well, I'm going to divide 15 divided by 3 times 4. Everything I need is right here on my page already. So how am I going to write it one more time? 15 divided by 3 times 4. So let's write that. 15 divided by 3 times 4. Let's simplify what we have. So I have a log base 3. On top I would have 15 and on the bottom I would have 12. that would be your final answer written as a single logarithm. So what log did they all have in common from the very beginning? Log base 3. Pull that out in front. From there we have to highlight what kind of symbols we're dealing with. And from there we just read our numbers, and it's telling us what to do. 15 divided by 3 times 4. Telling us what to do, telling us what to write. Let's try again, because we know practice makes perfect, or I shouldn't say practice makes perfect, not in math. Practice makes us better. Never perfect, right? So we're going to try again, writing as a single logarithm. So let me give you guys a moment. Please highlight and pick out the key pieces of this problem. Point to them. What is that symbol going to change into? Okay, so Anna, what's the addition sign going to become?
It's going to become this sign.
Good. And how about the subtraction? Division. Kayla, what log do they all have in common? 5. So log 5 is going to get pulled out in front. Now we just got to fill in what we have left. So what numbers are they talking about? 10 times 8 divided by 7. 10 times 8 divided by 7. I could even do these side by side if I wanted to. I could write it like that. That would be fine. But we're always thinking order of operations, so since multiply and divide are the same operation, I would solve them left to right. So I could say 10 times 8 is 80, 80 divided by 7. So log base 5, 80 divided by 7. So these look scary hard at first. You're like, this is a crazy long problem. It looks super intimidating. But take a highlighter, put what each symbol means, and then from there, you're just going to do what it says with your numbers. Just like you're kind of going up and down between the number and what you're doing to it. Number, what you're doing to it. Okay? Just takes practice. They're weird, I know. They're strange. So far we've learned two things. We've learned the definition of a logarithm, which takes any log and puts it back in exponential form. We've also learned how to take an expansion and write it as single logarithms using the rules on the last slide. Does anybody have a question about any steps we did so far? We still haven't been solving for any variables yet. We're just practicing setting up our problem. Okay, a couple more examples. This one I changed slightly from your notes. I took the 8 out. It used to be an x to the 8. So can you cross that little 8 out, please? This time I'm giving it to you as a single logarithm. I'm giving it to you small and squished. I want you to write the long version. So we're doing the opposite of what we did on the last slide. So let's back for just a second. The last slide I gave you the long version. We wrote the short version. This time I'm giving you the short version and I'm asking you to go back to the long version. So we're kind of undoing what we did. So you need to ask yourself, what's going on between the 1/2 and the x? What operation's happening there? They're being multiplied. When I expand it, what's the opposite of multiply? What did multiply go with on our chart? Multiply belongs with which one? Can you look back? Addition. Multiply belongs with addition. So see if you can write this in expanded form. You know, sometimes our brains don't want to go backwards. I get it. Okay, so in expanded form, if I have two different pieces of the puzzle in there, a 1/2 and an x, I'm going to have two separate log base 5. So my first log base 5 will have the 1/2. my second log base 5 will have the x, and then you guys just told me the sign that belongs between them is the plus sign. So that's considered the expanded form. Because what did they really do? They took the 1/2 and the x, and they changed it to a multiply. Why did they change it to a multiply? Because plus means multiply. It's just making our brain think one way and then making our brain think the opposite direction. So if I showed you a problem that had division in it, like say I gave you x over 3. Say in my little area was x over 3. What would division change into? Wouldn't be an addition anymore, right? What would it be? It would just be subtraction. Good job. So they're just trying to make sure, do you have the connection between what's going on in the logarithm and how to write it in the opposite way. See if you guys can do the bottom one. It says convert the expression to exponential form. That's just the log definition, right? Taking your log, putting it back with exponents. See how I keep having you practice here and there? See if we remember that very first rule I taught you. Does your answer make sense? It should. Okay, do we remember the rule? So it's going to be 5 to the, you guys help me out, 5 to the negative 2 equals, no, that's not what I see on there. What number's on there? 1 over 25. Remember, you got to use the numbers they give us, right? So here I have 5 raised to the negative 2, always raised to the other side, equals 1 over 25. That's true. Why is that true? What do I do with negative exponents? Do you remember? You flip them. So 5 to the negative 2 is the same as 1 over 5 squared. What's 1 over 5 squared? 1 over 25. Okay, good job. So it's just reminding you, the rule still holds true. You're always going to do the base raised to the other side equals this number. Even if it's fraction, totally fine. Totally fine. So I was just making sure we remembered from the beginning of the lesson how to write an exponential form. Okay, this I have erased on your slide. So let me just erase mine real fast. No peeking. So now we get to how do I solve problems. Not wanting to stick. There we go. How do I solve problems when I do have a variable that's an exponent? So far all we've done is set up problems, practice writing problems, but we haven't solved for anything yet. So this will be my first real chance to solve. So let's think if we already know my answer. If I said that x was a 2, 3 squared is 9. If I said x was a 3, 3 cubed is 27. Well, we know 10 is somewhere in between there, right? So my exponent answer is probably going to be 2 point something because it's in between 2 and 3. So how do I solve when I don't know the answer off the top of my head? Here are going to be your steps that you're using every single time. We ready? We're going to take the log of both sides. So do these steps with me. Okay, so we're going to take the log of both sides. Now, why am I allowed to do that in math? Think about it. What does it really mean if I'm adding the log to both sides? Anybody want to take a guess? Why am I allowed to do that? Mr. Hayden's like, don't ask me. Exactly, because whatever I do to one side, I can do to the other side, and it keeps my equation balanced. It's still equal. This is like saying times by a log, times by a log. That's the same as me saying times by a 2, times by a 2. You're allowed to do that as long as you do it to both sides. Now, one of our rules that we have not practiced yet was that power rule. Remember, my whole goal is to find out what x equals, correct? Which means I have to get x by itself. What was that power rule? What did it tell me I can do with my exponent once there's a log on both sides? Do we remember? Let me go back. We haven't used this one yet. It's this one. What am I allowed to do with that exponent once I have a log on both sides? I can put it in the very front. Exactly. It gets to move. So once I add a log to both sides, I'm allowed to take this exponent and stick it out in front. Let's do that. Stick it out in front. That means I have x log 3 equals log 10. My goal is still to know what x is, so my goal is still to get x by itself. How do I get x by itself? How do I get rid of that log 3? Think mathematically. What's going on between these two? These two are what right now? They're touching, which means they are multiplied. How do you get rid of a multiply in math? Divide. So I'm going to divide both sides by log 3. You are going to use this so much, it's going to be like second nature to you. So whenever you see an exponent that's a variable, how do you get the exponent out of being a variable? Take the log of both sides, stick it out in front, solve for x. So a calculator solves this portion for us. Does that make us feel happier? We don't have to do it. A calculator is going to do log 10 divided by log 3 for you. And when we do that, if you have your phone on you, you can grab your phone and put the calculator app open. If you tilt your phone sideways so that it's horizontal, you actually get a scientific calculator. Until you know your calculator is giving you the right answer, I want us to do it in pieces. So we're going to type in log 10 first. What do you guys get for log 10? People who have a calculator. What do you guys get? 1. Wasn't that one of those hints on an earlier slide? Anytime you have log 10, it's going to be a 1. What if we had ln e? That's also a 1, natural log. So on top, what am I going to have? 1. And on the bottom, I just need to work out log 3. So can you guys try log 3? And hit enter. And we get 0.477-ish. We're being very precise today. You get an ish. So when you do 1 divided by 0.477, we're going to get approximately, I'm going to use my wavy equal sign to say approximately, 2.09. Let's see if that makes sense. Let's come back to the very beginning. When I tried putting a 2 in there, I got 9, right? Isn't 9 pretty close to 10? So the 2 almost worked. When I put in a 3 there, I got 27. That's not really close to 10. So we knew my answer was going to be really close to 2. Guess what? My answer was really close to 2. 2.09 would be the number that would give us a 10. Does that make sense? Our answer has to make sense. If I got like 10, no, 3 to the 10 is not 10, right? Like our answer needs to make sense. Good job. I want us to try that idea again because I think in order to really grasp how to get that variable out, I want us to try again. So on the lines next to this problem, we're going to do one more. Let's do 4 to the x equals 10. Let's do 10. Can you guys try all of your steps again? Before we start though, can we sort of be thinking about what our answer should be? So 4 to the 1 would be 4, so it's not a 1. 4 squared would be 16. So 4 to the 1 is 4, and 4 squared is 16. 10 somewhere in between there. Would you guys agree with that? So by the time we're done with the problem, what should my answer be? Somewhere between 1 and 2. Okay, so go ahead, work on it for just a minute. Even if you don't have a calculator, just go ahead and set up all your steps and try them. So our first step to getting x out of being the exponent is you have to take the log of both sides, because you're not allowed to move exponents until you have the log of both sides. Next, that would come out in front, so I would get x log 4 equals log 10. We love that moving rule, by the way. That is so helpful, because that's getting rid of our exponent, right? That's our whole goal. Get that variable out of the exponent. So now that my x is out in front, I just have to get rid of that log 4. So to get rid of the log 4, we're going to divide both sides by log 4. Excuse me. So even if this was not a log 10 on top, which we know is a 1, even if you got a decimal, so what? You'd have a decimal divided by a decimal and you'd still get an answer, right? That's what calculators are for, not making you do these by hand or anything like that. So this would be 1 over, and log 4 is 0.602. So we end up with 1.66. And that makes sense because even before we started, we said, hey, my answer has to be somewhere between a 1 and a 2 because 1 gave me 4, 2 gave me 16, and 10 somewhere in between. It's just about halfway, right? Halfway in between. That makes sense. So good job. Yes?
When you're answering a question like that, would you do the first 2 placeholders after the point or the first 3?
So the question is, where do you round to? And the answer is, it depends on the quiz. So sometimes the quiz is going to leave your answer like this in log format and not make you divide it out. If they do give you decimal answers, you'll just have to see. Do they only give you 2 decimals? Do they give you 3 decimals? And you'll just pick the one that matches. They're never going to be like right close. They're not going to give you this as an answer and that as an answer. And do you see what I mean? They're not going to do that to you. So your answers will be very varied on a multiple choice test. So only one's going to make sense. Only one's going to be even close. How did those feel, okay? Kind of weird, kind of new, getting our exponent out of the variable status. So here we go. Don't get scared. Okay, so ask yourself, what's different about this one than the last one? There's only one thing that's different. Anybody see what it is? It has the +1. What do you think I need to do with that +1 before I start? Great job, Anna. So she said, I'm just going to move it. Because once I move that, now this is the last problem you guys just did with me. Exactly the same. There's a 5z. Yep, there's a 5 up there, but we can deal with that. So once I got rid of the 1, would you guys agree now it looks like it always did before? So how am I going to get rid of the exponent? I have to do the what to both sides? Log. So let's take log of both sides. Once you have the log of both sides, Billy, what can I do to my exponent?
You just switch to the left.
Yep, I just put it out in front. Awesome. I like when steps are the same, don't you? Process for solving. 5z log 3 equals log 219. Okay, this one's a little different than last time, still looks a little strange. I want z by itself. How do you get rid of 5? How do you get rid of the log 3? So you ask yourself in your head, how are they all related right now? Got to do the opposite. So you tell me, they're all touching right now, which means what? They're all multiplied. So how am I going to get rid of the 5 and the log 3? I'm going to divide. Good job. So don't let it trick you just because there's more pieces to the puzzle. It's the same steps. That gets rid of the 5. That gets rid of the log 3. We don't care how crazy messy the log looks on the right side because our calculator is going to do that for us. So our final answer would be z equals log 219 divided by 5 log 3. What I want to caution you guys about when you're using your calculator is doing too many steps at one time because your calculator will not always do order of operations for you in the right order. So that's why I would calculate the top part, put your decimal answer, calculate the bottom part, put your decimal answer, and then divide last. Does that make sense? Don't type in everything because your calculator is not as smart as we are. They don't always do things in the right order for us. So on this particular question, they would leave it like that on a test. That would be your answer right there. Okay, so I'm going to skip this next question because it's the same. And I do want to talk about on your computer how you find your calculator. So usually these can be found under your accessories tab, your start button will have a calculator. And if you pick your view, you can actually switch between basic and scientific. So if you choose scientific, then you're going to see these logarithm buttons show up on your calculator on your computer. So you guys either have your phone to use, your computer calculator, or you could even Google like free graphing calculator or free scientific calculator, and they will all have log buttons on them. So the best thing to do is to find a problem where you know the answer, like in one of your online slides that you guys have with the lesson, and try it on your calculator and make sure you're getting that answer. Because some calculators will make you type in, like say I wanted that log 219 from the last slide. Sometimes you'll have to type in the 219 first and then hit log to get your answer. Sometimes you have to hit log first and then the 219. So it depends on your calculator. So again, the best thing to do is have your calculator out when you're doing your online lesson and try one. Because you know they give you all the answers, right? Just make sure that you are getting the answer that they got. Because the order matters depending on your calculator. So calculator messages. If you ever try to take the log of a negative number, you'll get an error message. So you can't ever say like log of negative 10. Let's think about why you're never going to have negative logs. Because even when your exponent's negative, what do you really have? A fraction, right? 1 over 10 squared. So you can't ever have negative logarithms. Just a little quick note. Because here's kind of the question. What power can you raise a number to that will get you a negative number? Like what could I put in here for my question mark that would get me a negative? There isn't one. It's like a trick question. There's not one. Because when we have negatives, they become fractions. When we have positives, they become whole numbers. So you're never going to have negative logarithms, which is why a calculator will give you an error message. So if you try typing something in and you get an error, you have to ask yourself, ooh, what did I do wrong? Calculators can't do negative logs. All right, last thing I'm going to show you today, and then we'll call it a day. And I know this has just been a lot going on. So sometimes you're going to use the logarithm definition. This is the one we've been doing all day, right? The 3 raised to the x equals 81. Sometimes we get to do that method, and we really like that method. Right? We like that method. We like that a lot. It's easy. Going back and forth is easy. Sometimes you're going to have logs on both sides. So here's the difference between the two. The top one, you only have a log on one side. Then you're allowed to write it as an exponent. Easy. The bottom one is when you have logs on both sides, and I have to teach you one last property to use. And again, I know this is a lot, but you're thinking this is like 5 days worth of math in one small little hour with Mrs. G. So you'll have plenty of time to practice this stuff on your own. So first we're going to decide, am I going to use the definition or am I going to use the logarithm property? So just look at my 3 examples on the next slide, and we're just going to do a check mark under which category it fits into. So take a peek at my first example. Are there logs on both sides? You guys say yes. We'd have to use the property of equality. Can you put a check mark over there? Example 2. Are there logs on both sides of the equal sign? Yes. You'd have to use the property of equality. Example 3. Are there logs on both sides of the equal sign? No. See how it's only on one side? There's none on this side. So that means we could use the definition of my logarithm. So the first thing you're going to do when you guys get to your homework is you're going to identify, are there logs on both sides? Or is there only a log on one side? So now what do you do with this information? Okay, Miss G, I can see that there's 2 logs or there's 1 log, but now what does that mean? What do I do with it? So my last 2 examples are going to show you what we do with it. Okay, so are there logs on 2 sides or 1 side? 1 side. Yay, we like those. Those are our definition rule. Remember our definition rule from the beginning? So 6 raised to the what power? We're all looking at the problem together. 6 raised to the 4th power equals what? What's there?
2x plus 8.
Thanks. 2x plus 8. That's your basic definition property. How did I know? There was 1 log. I can solve that. I can say, hey, 6 to the 4th, because see how I remember, my whole goal is to know what x is, right? Always get my unknown. I can solve this. 6 to the 4th power is 1296. This is an Algebra 1 question. How you get x by itself, right? Move the 8, divide by the 2, and we'd be all done. So by the time I do all that, it would be 1288 equals 2x, so my x would equal 644. Sorry, it's at the very bottom. 644. So one more time, how did I know I could go straight to my definition? Because how many logs did you guys see? 1. Whenever you see 1 log, you can go straight into that rule. See how it didn't even matter that there was more than 1 number there? It still works the same way, even with variables. It's cool. Once we get used to the format, we can still use the format always. These are our favorites. When you see 1 log, easy. We got those done. Down pat. Last problem of the day. How many logs do you guys see? 2. They're on both sides of the equal sign, right? These are a little tougher. So this time we have to use the property of equality. Okay, so before we start this one, let me remind you of one thing. And this is like a pretty hard homework problem, to be honest with you guys. So think about this. If I had 3x equals 3 times x plus 6, what can I do with the 3's on each side? I can sort of cancel them, because really what would you be doing to them? Divide both sides, right? So in math, if there's something multiplied by both sides and it's the same, can't I just cross it off? I am allowed to do that. Kind of cool. This time, what do you guys see on both sides that's exactly the same? Do we see the log 9s are the same? Okay, so eventually I get to cross those off, but not yet. There's a number in our way first, and it's the number that's out in front. So this time we have to use that power property in reverse. We have to use the power property backwards. Do you guys remember when I had, in the last problems that we did, when I had like log 9, 10 cx, I could take the x and put it out in front. You guys agree with that? We were practicing that a moment ago. How would I do that in reverse? What can I do with this 2? So it's not just on the right, but it will become the exponent. What can I do with this 1/4? It can become the exponent. So I'm doing the property in reverse. Let's try writing it like that, and you're going to see why I want to do that. We're really close to being done, even though it still looks scary. You guys just did the hardest part. So what did I do with the number out in front? I put it back as an exponent. Now, why did I want to do that? Because now check out your log 9s, your log base 9, log base 9. They're exactly the same on both sides. What can I do to them? I can cross them off, because that's the same as saying divided by log 9 on both sides. That's handy. All that nasty logarithms, they go away. So I'm left with b squared equals 81 to the 1/4 power. You're so close to being done. We just need b by itself. So let's think about what these fractional exponents mean, because this is what we worked on last unit. When I change it, that's like saying 81 to the 1st power, but I want the 4th root of it. Remember, the top number becomes your exponent, the bottom number becomes your root. So if I break 81 down into all of its factors, there's a number times itself 4 times that's 81. Anybody know what that is? 3. So instead of saying 81, I can say 3 to the 4th power. When our index matched our exponent, this base got to come outside, so 3 gets to come outside. Almost done. We got b squared equals 3. How do we find just what b is? So I'm going to move it up here. B squared equals 3. You're this close. How do you get rid of a square? What's the opposite of squaring something?
Square root.
Square rooting. Good job. So b is going to equal plus or minus square root 3. You guys were there, just that very last step was all it was missing. So I think what you're seeing is that we're using a lot of our old skills in our new skills too. There's a lot going on. So for today, your week 7 essential question is, why do we use logs? And then I'd like you to describe the steps to solve this problem, meaning how do you get that x out of being the exponent? So make sure that you give me the final answer as well as your steps in the Dropbox. So thanks to the two ladies joining me online. I'm going to go ahead and log off now, but make sure that gets in the Dropbox for week 7.